Good evening, all. I have great pleasure in welcoming all of you to today's webinar, a lecture on education and research in emerging and disruptive technologies in higher education institutions by Professor V. Kamakoti, Director, IIT Madras. A special welcome to Professor V. Kamakoti, who, in spite of his very busy schedule, agreed to give this lecture. Thank you very much, sir. I also welcome all the fellows, associate fellows of INAE, and all the members of the Chennai chapter of INAE and all other invitees and participants to this event. This is the 6th main event organized by INAE Chennai chapter. Now, a brief introduction to Professor Kamakoti. Professor Kamakoti Veezhinathan received his MS and PhD degree in Computer Science and Engineering from IIT Madras. He joined the faculty of IIT Madras in 2001 and took over as its director in January 2022. He specializes in the area of computer architecture, information security, and VLSI design. He heads the microprocessor development program and the information security education and awareness program at IIT Madras, funded by the Ministry of Electronics and Information Technology, Government of India. He is a member of the National Security Advisory Board. He was also the chairman of the Artificial Intelligence Task Force constituted by the Ministry of Commerce and Industry, Government of India. At IIT Madras, he has served as a chairman JEE and as associate dean, industrial consultancy and sponsored research. He has over 150 publications in international journals and conferences, guided many research scholars for their PhD and Master of Science by Research program. He has coordinated and successfully delivered close to 50 projects from industry and government R&D establishments. He serves in the technology committees of the National Stock Exchange and Reserve Bank of India. Dr. Kamakoti is the recipient of DRDO Academic Excellence Award, Indian Electronics and Semiconductor Association Techno Visionary Award, Abdul Kalam Technology Innovation National Fellowship, ACCS Lifetime Achievement Award, IBM Faculty Award, and Vasvik Industrial Research Award. So after Kamakoti finishes his lecture, there will be a question and answer session. Professor Nandita Das Gupta will moderate that session, and there will be also a vote of thanks. Professor Kamakoti, it's now for you to take over.
Thank you, Professor Narayan. Thank you very much, INAE, for inviting me to give this lecture. What I thought that as we are proceeding in our Amrit Kal towards the 100th year of independence, just 25 years away, the big need that comes when we aspire that our country becomes a technology superpower, there is a need for developing Atmanirbhar, extremely self-sufficient technologies, both for our strategic and civilian needs. And based on this, there was a survey conducted where we just wanted to find out what IITs are doing, right? There is a very nice picture that we got, and I thought this will, being an Indian National Academy of Engineering, I thought this will be very apt for me to present here some of the education and research initiatives that are happening among the IITs in these emerging and disruptive technologies, so that we are developing a very strong foundation platform to address the bigger needs that will come in the near future and in the long future, and that how we can scale this up to become a technology superpower as we touch 2047, our 100th year of independence. So this is the entire backbone behind this talk, and I thought this is the best forum where I could make this. So friends, we are now moving towards Industry 4.0. The Industry 1.0 was mechanization, the steam, water and steam power. The second was basically driven by electricity. The third industry revolution was by computer and automation. And when we touch this Industry 4.0, we are looking at cyber physical systems, which are basically systems that do a lot of sensing activities, which can also create certain actions at the field. So there are some actuators and control systems involved there, and also generate a lot of data which can be used for monitoring and certain preventive care, etc. Now, the entire world is being driven towards this cyber physical systems, which are small systems connected together in the cyber world, basically through an internet. Now, this Industry 4.0 is to be powered by a combination of disruptive and emerging technologies that is expected to provide a transformative impact on both the society and also the economy. So, all that we are talking of today will have a very strong economic impact and also a social impact. And as we march towards this Industry 4.0, there are the entire beneficiary, as you see, can be basically arranged into these a stack of three layers. The topmost layer are the application areas. So Industry 4.0, how will my agriculture look like? How will my fintech look like? How are my logistics in place? Healthcare, space. So there is going to be a different view of these application areas as we move on to the Industry 4.0. Days are gone where we need to start inspecting each plant to find out if there is a disease. There are no high resolution cameras which can basically take the picture and send it to a cloud, which can an AI based analysis could be done on the image, and a prediction of a disease or a prevalence of a disease or existence of a disease can be communicated. Similarly, there are a lot of issues that come on fintech, logistics, healthcare, etc. Now, these sample application areas are being enabled, the basic building blocks for building such applications which are intelligent, which which are data driven, etc., are fueled by certain emerging techniques which include artificial intelligence, data science, simulation and modeling, secure systems, and intelligent manufacturing. So if I want to have a agriculture drone, there will be some amount of edge intelligence there. There will be some amount of data that is sent, images that are sent, which are processed, and some intelligence happen at a cloud. A lot of data science is required there because we collect the data, and based on the data only we can go and make a decision about something is a crop is disease prone or not. A lot of simulation and modeling happens before actually these AI algorithms and systems are evolved. And many places, security also becomes a very important thing. For example, healthcare, where the system needs to be secure from hack and also any malfunction. And then a lot of intelligent manufacturing is necessary. So these are all the basic emerging techniques. And there are certain basic building blocks that basically on which these emerging techniques are used to build these sample applications. And the basic building blocks are most important emerging technology that is needed by every country is a high-speed internet access and a high-speed mobility. The role of 4G, 5G, and subsequently 6G, 7G, 8G, etc., are going to aspire to bring this high-speed internet access or high-speed mobility. In addition, high-performance computing, sensors, IoT, and embedded systems are also basic building blocks for this. IoT stands for Internet of Things. So those also become extremely important basic building blocks of this. And then there are advanced materials and renewable energy sources, and then 3D, 4D printing, cloud technologies, etc. So there are certain basic building blocks based on which certain emerging techniques are used on top of it, using that, and then very good sample applications are built, giving very good results in terms of monitoring and also scheduling, etc. So with this as a stack, any emerging technology or any disruptive technology should find some place in this stack. And so this is perhaps the reason why I put this entire stack at this point of time. And now what we will see in the subsequent set of slides is where are the IITs contributing to both these emerging techniques and basic building blocks, and also enabling a very strong foundation for building state-of-the-art applications, which is the top layer. So we'll now go ahead and see some of these interesting contributions of IIT. So what is a cyber physical system for people who are new to this concept? The Arogya Setu, I hope many of you would have used it, is an example of a cyber physical system. How does Arogya Setu work? If two persons A and B have installed Arogya Setu and they have kept the Bluetooth on and come in close proximity to each other, the device ID of A gets stored in B and vice versa. So when A and B comes close to each other, there is an ID exchange happening between the mobile phones and A and B, provided they keep the Bluetooth on and they have installed Arogya Setu. Now, at some point of time, if A tests positive, then the details in his mobile are copied in a secure fashion to cloud and processed to find out who should be warned or notified, right? Because all that is stored in A's mobile after he tests positive or those who are coming close touch to close contact to A, and so essentially that data is gone to the cloud, and and the cloud will decide whom to warn, and in this case, since B was at proximity to A, B will be warned. Right, so this is how simply this Arogya Setu works, and it's an example of a cyber physical system, in my opinion. And this is currently used by over 19.5 crore users across the country. And that involves sensor. So when we look at this cyber physical system, what are the things that it involves? It involves a sensor, which is a Bluetooth in this case, because I'm using a mobile phone with Bluetooth. It needed a local integrator, aggregator. In this case, it can be the mobile phone. And then there'll be a data transmission to cloud. And then finally, there'll be some processing by cloud. So these are all some of the very interesting, important aspects of Arogya Setu, which makes it, or we can classify it as a cyber physical system. So typically a cyber physical system will have a sensor and will have an aggregator which will take the sensor data to the main processor, and in this case the local aggregator is mobile phone, and then that from the mobile phone there is a data transmission over the cloud, and then there is a processing by the cloud. So this is an example of a cyber physical system. Now, what is the big picture here? We are looking at unity in diversity. That is, we are looking at a single window interdisciplinary platform, a single window interdisciplinary platform, which is specializing on sensor manufacturing, sensor testing and characterization, sensor interfacing with control systems, and also establishing command and control through actuators, and networking the sensor to aggregators, secure data transmission to the cloud, and decision support systems to the cloud. So a lot of things are covered in actually evolving a cyber physical system, as we had seen in the simple case of an Arogya Setu. So education and research in these emerging and disruptive technologies is a must focus on such type of platforms which bring in large diversity into a unity. So this is the overall big picture, and in this direction, let us go and see what else, what the IITs are doing. In addition to whatever we are talking on Industry 4.0, in the scheme of things in Industry 4.0, medical sciences become very important, specifically not medical sciences as we see in the MBBS, etc. This is medical sciences which involve a lot of medical technology. Today we have lot and lots of equipments that we have purchased from foreign countries, and now if you want to replace them in India, there needs to be a lot of concentrated efforts to bring in. And many of these Department of Medical Sciences actually aspires to bring such medical schools into the respective campus. Now, why is medical science very important? So when a scientist actually, medical doctor actually starts learning science or engineering, uh, then they are called as physician scientists. And the role of such physician scientists is to bridge the divide between medicine and science. Physician scientists are those who tie the bench and the bedside, right? So this is very, very important. And they are trying to conduct independent specific investigation in the laboratories, clinic health services, population health, community segment, engagement, and health equality. So, once we have a medical science intervention of medicine, intervention of engineering, top engineering schools into medicine, one such output we get is that of uh, uh, this physician scientists, and this is what we can expect out of them. 37% of Nobel Prize winners are actually physician scientists, and they play a very key role in pharma industry. 70% of the CSOs at top 10 pharma companies and NIH health institutes. There's a 60 plus year old 100 such programs in the United States, and we are yet to start one. And most faculty appointments in the United States medical schools are also from this point. From this. So ultimately, there is a need for what we call as the MD PhD program, where a doctor actually starts learning lot amount of engineering. And so these physician scientists who complete their MD PhD would be the driving force behind the mechanistic understanding of the diseases, development of therapies and diseases and devices and technologies. And roughly 60 to 70% of all the FDA approvals, policy guidelines, etc., are dictated by patients' diagnosis. So, treatment and recovery time have been influenced by the work of physician scientists. And many causal relationship linked between sugar and diabetes, smoking and cancer, etc. All these are got because of physician scientists, not just physicians. And heavy dependence on imports of heavy dependence on imports of medical devices is also a very important agenda that we need to take care, and there is a need to revitalize the medical device industry. And then the last one, the comparing to the need for MD PhD program, there is a need for India-specific research on high prevalence of non-communicable diseases. And this is also becoming extremely important from the MS point of view. Right? So these are some very important need for the medical intervention of technology into medical schools. Now, we have seen Industry 4.0. We are also seeing some very interesting and important data points with respect to the medical technology schools. And let us now see what are all the education initiatives that are happening in the higher education institutions in the country. And let us take stock of it and see what's happening. Now, there are a lot of courses for the new era, right? And there are courses on 3D mod, some courses which even last generation, that 5 years before, would not have even dreamt of, both at an undergraduate and also at a postgraduate level. Some of the courses that are very relevant to emerging and disruptive technologies include course on 3D modeling, 3D printing, laser processing. This is taught at BTech first year in IIT Bhilai. Then there are a lot of BTech, MTech and PhD courses in data science and AI, mechatronics, electric vehicles from IIT Bhilai, and also MTech in electric vehicle technology from IIT Indore. IIT Madras essentially has a set of interdisciplinary postgraduate program. We have actually 11 of them now. There are 2 missing here, which spawns from advanced materials and nanotechnology all the way to quantum science and technology. There's also one more on There is one more on, there's an MA program on policy that has been recently introduced as a part of this interdisciplinary postgraduate program. And there's also a quantitative finance program. So totally 11 programs we have that are interdisciplinary postgraduate programs from IIT Madras. And then IIT Hyderabad has a lot of courses, lot of new type courses like MSc in medical physics, integrated sonar systems, medical device motivation, e-waste resource engineering and management, and many courses that are unique interdisciplinary courses, MTech programs that are made available. In addition, data science and management also goes together. There is a very strong relationship between IIM Indore and IIT Indore on the areas of the four pillars of the data science and management, namely the data, the enterprise strategy, technology, and people. So there is a joint degree program between IIM Indore and IIT Indore. Then there are joint masters and PhD in medical technology between IIT Jodhpur and AIIMS Jodhpur, MTech in clinical engineering between IIT Madras, Sri Chitra Tirudal Institute of Medical Sciences, Trivandrum, and Christian Medical College, Vellore. Then there are very other interesting programs, specifically at IIT Jodhpur, on robotics and mobility systems, mathematical and computational economics, brain science, and digital humanities. IIT Madras has also introduced a 4-year BS data science and programming here. Some of the salient features of this is 1/10 of our total admission. We have total 12,000 admission, and currently whatever you are seeing on the screen is 110 students. There's 1,000 students, and we have more than 12,500 students enrolled in this program. 1/10 of the students is what we are seeing here. The very important characteristics of this program is there is no age bar, there's no entrance exam, there's only a qualifying exam. And this is a web-enabled course. Am I audible, Professor Narayanan?
Yes, you are
Yes,
audible.
you are audible. Yeah, you are audible. Yes.
Okay. So this basic program does not have any age bar, no entrance exam. It's a web-enabled mode. We have admitted around 12,500. Recently, another 5,000. So 17,500 students are studying here. And there's a multiple exit option. This is again very coincidental to the aligning to the national education policy. So at the end of first year, they get a certificate. Second year, they get a diploma. Third year, they get a BSc degree, and the fourth year they get a BS degree. So there are multiple exit options depending upon the need and availability and what the student feels they can do, and they can do at their own pace. It's a slow pace completion. So all facets of an ideal learning environment is available under this degree program, and this has grown now from to around 18,000 students whom we are in different stages of this program. On the research initiative, all important initiatives are here. So I try to capture many of these emerging and disruptive areas initiatives. On the quantum side, quantum key distribution link is actually demonstrated by IIT Delhi. There are a lot of quantum device development that are happening, basically driven by MEMS at IIT Goa. And there are a lot of post-quantum cryptography and quantum communications that are happening at IITs and IISc. On the health side, there are a lot of health devices that are made. There is a health device, or whatever you are seeing there, it's a IIT Delhi product which can detect dengue virus and HIV in 1 hour, which is a very important life-saving drug. We can also, there is a life-saving life-saving, it's detecting dengue virus within 1 hour. It's a very important life-saving diagnosis that is part here. And there's also IIT Delhi has also come out with first ever point of care devices with a patented technology which detects gram-specific bacterial biomarkers in human plasma under 10 minutes. And this is very, very important for neonatal sepsis. Then there is a lot of Ayurtech initiatives. These are technology innovation for Indian medicine system, which is done both at IIT Jodhpur and also at IIT Madras. Now, this is one very interesting development by IIT Bombay, which we call as the CAR-T therapy technology, which is used for curing cancer. This basically patented, and the technology transfer has happened to a startup company there, ImmunoAct, and close to raised 9 million USD now. And what is the impact of this? This is for cancer treatment. In the absence of this, the cost would be at least 90% more. This has got a cost reduction of greater than 90%. And because of that, it can enable this access of technology at an affordable cost to many. And there are a lot of development of novel product and platforms beyond this. One of the important thing here is that this can enable the same cancer therapy at a lower cost. Otherwise, this is something very, very important. Otherwise, this a normal treatment of CAR-T takes around approximately rupees 5 crores per patient, which were now brought to 10 to 15 lakhs per patient. And that is something, is a phenomenal impact, phenomenal societal impact. IIT Hyderabad is developing a low-cost ventilator, which was actually, the need for the hour when the pandemic struck. And then there are a lot of smart healthcare plus IITs plus IIC sort of things that are happening on the smart healthcare, which is predominantly driven by AI. So AI for disease diagnosis, a lot of groups are working on it. Portable health devices. There is also portable health devices. There are drug discovery and treatment protocols for rare diseases that are happening at IIT Jodhpur. IIT Delhi has also come out with a high performance medical textile, which will destroy 99.9% viruses within 30 minutes. And they are now in the stage of large scale manufacturing with industrial partners. So what you see on the left-hand side top is a device from IIT Kanpur, which is for preventive measure to avoid ventilator-associated pneumonia. And then a lot of work happening at IIT Mandi, right, which is on a new molecule that they have found, which will be used for treatment of diabetes. And then IIT Mandi also came out with a Himalayan flower petals that inhibit SARS-CoV-2 infection. I fondly remember the Ramayana when Hanuman actually bought a herb from Himalayas to save Lakshman. I think this is also a herb from Himalayas. Then there are a lot of synthetic sequence-defined polymers for design of them for anti-cancer drugs. And a lot of these type of activities also happen here. The next important thing, other than medical and whatever quantum that we are seeing, is Atmanirbhar assistive technologies for the disabled, physically challenged, the Divyang people. So there's a 4D printed exoskeleton hand by IIT Dharwad. 4D is nothing but 3D plus the whole thing, the whole exoskeleton that we have here will adjust itself to the movement of the different movements of the body parts. And that is the fourth dimension that we add. So 4D printed exoskeleton hand. Then there is what you see on the below this, a 4D printed simple gripper mechanism is from IIT Dharwad. And then there are a couple of assistive technologies. What you see on the right hand side top is a Neobolt motorized wheelchair, which can be used by uh, by the physically challenged people for mobility. And then artificial feet, which is now in market, is also developed by IIT Madras. One of the big projects that are taken is the artificial heart, and IIT Kanpur is doing very well on the advanced left ventricular assist device, what we call as the artificial heart. A lot of things need to be done for agriculture in the country. So there are many efforts. I'll just put two or three of them here. There's a complete precision agriculture for small farmers that is happening at IIT Dharwad, and they are looking at early stage disease notification or identification, data analysis to provide. Is it moving? No. So a lot of efforts have been taken for the farmers here. There's a precision agriculture for small farmers, uh, which is done in IIT Dharwad. There are a lot of things that are happening there, from crop and soil health monitoring, early stage disease identification, data analytics for various crop related aspects, a lot of things on post harvest preservation, etc. It's a complete stack for precision agriculture. At IIT Madras, we have taken up this regenerative agriculture stack architecture, which is basically trying to have processes for both from farm to kitchen and reverse. Where farm to kitchen, there is a food product that is coming up, and in the reverse, there is a commercial transaction that goes for that. And a lot of sensor interventions and digital twins are under development under this head. And then there is a whole full agriculture and water technology development hub, Awadh, in IIT Ropar. And then there is a lot of automation related company looking at agriculture, like IoT based harvesting and post harvesting irrigation, etc. So a lot of work is happening for the farmers, which is agriculture is going to become very important, and especially organic agriculture becomes extremely important. And this effort will will be a very important one for the country. Now, just moving from agriculture on the sample areas like medtech, etc. Now we go on to the building areas, technology building areas. There is a large area additive manufacturing setup for 3D printing of rocket components set by IIT Hyderabad. There's a 3D metallic printing and additive manufacturing at IIT Jodhpur. And then a lot of Atmanirbhar uh, micro 3D printer from IIT Indore, which will be trying to print very thin membrane. It can print a 3D using a 3D printer, a very thin membrane or thin film. This is very important for many applications, including micro heaters, strain gauges, and other structures that, as you see on the slide. So these are all some of the technology building aids in which we are working. On the building automation side, there are a lot of smart windows for power saving is done by, there's a project at IIT Indore, which basically looks at low cost, flexible, hybrid uh, device, which will basically stop the sunlight from coming in. Essentially, it'll make the entire total heat inside the room lesser, by which you use less amount of air conditioning. So there are certain very good smart windows that will eventually lead up to power saving. And then there are the IIT Madras has come out with a 3D printed house. It's completely printed using a 3D printer, and this is an answer to many of the quick ways of building small things in the country. On the space technology side, you would have seen a couple of days before the rocket from Skyroot actually has gone to has been shot. It has gone up to 90 or 100 kilometers. And so that was the first test, and that went off very well. Uh, uh, Similarly, there are multiple startups inside our campus. Cool, for example, is one which is ready to launch such type of what you say as the low Earth orbit uh, 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 rockets, which can take these low Earth orbit satellites and put them in that range, say around 350 kilometers, etc. So, so this is something which is very interesting, and in this type of rapid launch facilities, and the entire rocket here is 3D printed. They can print 4 rockets in 72 hours, 4 rocket engines in 72 hours. So this is how the space technology actually is being encouraged in the country. And there are a lot of other things that are happening. For example, disruptive technologies for mining is happening. Mining is a sort of a very dangerous job, very risky job. And how do we bring in certain safety features into mines? And also looking at autonomous systems for mines without involving human beings. And then there's a lot of digitalization of the mining process in a harsh and dynamic environment is a very important aspect. What they call as the pit to port optimization of how very quickly coal extracted from a pit can go to the port for export. So this is something which is very important here. And many of these solutions are handicapped by the non-availability of the many of them are handicapped because of the non-availability of location information, and that's also being taken care with an underground positioning system which will take care of this particular aspect. So there's a lot of disruptive technologies that are happening in the case of. Then comes the last one. There's a 5G, last but one. There is a 5G. There's an end-to-end 5G test bed. It's actually created by IIT Madras, and for the first time in the history of 3GPP, the third generation project partnership, an Indian standard got accepted in the international standard. This is one of its kind, and it has been accepted. And as you see here, the partnering institutions are IIT Bombay, IIT Kanpur, IIT Delhi, IIT Hyderabad, IIC Samir, and IIT Madras, along with many industry partners. And the 5G test bed is ready. People are already coming and utilizing it to see how things are happening. Okay. And the last down, there is also a need for spectrum sensing. And there is an effort taken by ISM Dhanbad on smart spectrum sensing using Atmanirbhar cognitive radio antennas. At IIT, we are also planning to have an hyperloop. It's a 550 meters track that will be ready in the next 6 to 8 months. And this is a hyperloop is a concept where the train passes through vacuum at more than speed of light, and then speed of sound, sorry, and then it basically goes at supersonic speed. It can, in principle. We are looking at something like 600 kilometers per hour speed, much less than sound. But then this is what we are trying to see, and let us see how fast it can travel on the vacuum tube. And if this is feasible, then we are looking at a 35 to 40 minutes travel from Chennai to Bangalore. So this is the next generation mobility, and this project is up at IIT Madras. We are setting up a test track for 550 meters demo within the next 6 to 8 months. The last year, there are a lot of technology development happening specifically for the strategic agencies, technology development for high altitude, not just clothing here, but also vehicles that can ship and people here or ship some vehicles, autonomous vehicles that can basically be useful for terrains and uh, and then waste management, etc. at high altitude. So these are all taken by IIT Jammu. It's very close to the Himalayas, the closest IIT to the Himalayas. And then there are a lot of things that are happening on the account of digital twins. So we'd like to create one twin, which is a twin of some physical system as a digital simulation model. And that's what we call as a digital twin. And there are a lot of technology being developed for preventive maintenance of machines, modeling of systems, and simulation studies. So we would like to see how the machine will behave 100 years old. Then we take a digital model of it and advance the clock for 100 years and see how this system will function at that point of time. So there is a lot of predictive mechanisms that we build around digital twins, specifically the what if scenarios getting answered. There's a lot of virtual reality and augmented reality that's happening. Specifically, these are extremely useful for immersive skill training and also heritage structures and tourism here and medical applications. The IIT Roper has actually a Center for Applied Research in Defense and Security cards, which focus on a lot of services, lot of applications for the tribe services, paramilitary and police services. And then there are a lot of initiatives on cybersecurity and blockchain. Uh, the entire land record management of IIT, land record management of 6 districts in Karnataka, it's called the Kaveri blockchain system, has been implemented, and it is done at IIT Kanpur. And there are a lot of effort on blockchain technologies, academic proof, etc., which are other important research initiatives. And there's also a lot of work done on IoT-based systems, specifically the structural monitoring, health monitoring is happening almost in all the IITs, and also monitoring of landslide, etc. by IIT Mandi. So one of the important thing is these devices have to be battery or solar powered, and portability will also be issue. So that is also something that is addressed here in terms of all these IoT based systems, specifically for high altitude, must run on solar power. And then there is a lot of waste to wealth initiatives, and which is basically converting garbage disposal to management. And this is something extremely important from a sustainability perspective. And so this is a very important project. And then a lot of battery technologies as we march towards EV, we are finding already very big shortage for lithium-ion batteries. And this has to basically the battery technologies has to build up. They should be light in weight at the same time. They should deliver large, long, long whatever. If you drive a car, it should give a long range, and at the same time, it should be quickly rechargeable and, of course, at affordable pricing. So there are some efforts. Today, we see a lot of cars getting burnt because EV is getting burnt, and there are efforts to see that uh, the battery doesn't get burnt. And there are some very interesting research that are done. So these are all some of the very interesting technologies I thought I need to present to all of you, done by the IITs. And these are all niche areas, and these are technologies that are needed in the near future. And these technologies are almost Atmanirbhar. Of course, there are places where we need to use some foreign or many foreign tools, etc. But more or less, uh, this is uh, this is very very important for us to take forward. And as we move towards an Atmanirbhar India, uh, this particular survey of what IITs are doing is very much in alignment with this. And So let us hope that many of the technologies that are presented essentially becomes marketable, they become products, and then do both create a social and an economic impact. Thank you very much. Questions?
Thank you, Professor Kamakoti. Professor Nandita, you can take over and moderate the question and answer session.
Yes. Thank you, Professor Narayanan, and thank you, Professor Kamakoti. I think we are now open to questions. You can either write your question in the chat box, or you can I think the INAE digital team will allow you to unmute you, and then you can raise your hand, and then you will be unmuted, and then you can ask the question. Otherwise, you can also write your question in the chat box.
Ma'am, we will do one thing. We will unmute all the attendee, then he can ask himself. Will it be better?
Okay, that also we can do. I mean, let us try that.
Yeah, now attendee can ask any question if he has any.
Good evening. Can I raise a question here?
Yeah, sure.
Yeah.
Please identify yourself.
Yes. Good evening. My name is Sharif Babu. I am from Garuda Aerospace. I'm Chief Agriculture Officer here. We also have Tech Stack Office at IIT Research Park and building number 2. It is indeed a very a wonderful presentation by Professor Kamakoti about the various development all over India and the exciting possibilities and technological advances. I would like to take this opportunity to express our areas of interest, which IIT Madras, if it could help, will be definitely beneficial to not only industry but the agriculture sector also. Sir, I am sure you are aware that there is about 150 million hectares of agricultural land, which the power sprayers are the present medium of spraying all over India. And to replace that with agricultural drone, the immense benefits it brings, like bringing down the total pesticide spray to 70 to 30% less, and immense benefit to environment, other sessions. We will need at least about 2 million drones. And for 2 million drones, we really need a lot of what you call infrastructure support. Important. I will only point 5 things which, if support from IIT comes up, it will be really beneficial to both the industry as well as agriculture. The first thing is to develop a fully autonomous agricultural drone. One. Second, set up an agricultural cyber physical system. In fact, I would love to call that as Arogya Kheti, like in terms of like what Professor Kamakoti was mentioning about Arogya Setu. I would love to call it Arogya Kheti. And the third is the perovskite thin film solar cells for charging the drone. In fact, VVLOS drones, when they are going to be released, the charging of batteries for the drones is going to be a challenge. And if we come up with something like this, it will be going to be very useful. The fourth point is graphene or boroflume batteries. Let us initiate a program to develop such batteries, not lag behind the Western countries in this area. And the fifth and final point is to develop a blockchain platform similar to Ethereum platform on which all agricultural applications can be, DApps can be, developed, as well as, if such blockchain platform is available on which fintech apps are, developed, then KYC becomes easy because it's immutable, verifiable, and accountable. These are the 5 points I wanted to make. Thank you very much for listening. Thank you, sir.
Thank you. Professor Kamakoti, would you like to respond?
Yeah, thank you, Mr. Sharif. I think it's a very interesting and very important stuff. As I showed in my slides, we are having this RASA, what we call as Regenerative Agriculture Stack Architecture, which is an initiative taken by IIT Madras. And of course, there are many other initiatives on agriculture. IIT Dharwad has a very good precision agriculture. So as an IIT is put together, we have answers to all your questions, starting from your fully equipped drone, your Arogya Kheti that you have been talking of, a blockchain type of interface to this, and the other battery technologies that you have been talking of, and a solar powered drone. And we have people at the research park itself. Since you are part of the research park, you will be knowing many of these people who are there who can solve your problems. One of the things is that you can share to director@iitm.isc.in, my email address. You can share your contact number. I will basically ask the RASA chief, the Regenerative Agriculture Stack Architecture projects chief to get in touch with you, so that we could look at your we can look at your requirements and see how it matches on to what our constituent members of RASA can offer to you as a solution. Thank you very much.
Thank you so much, sir. Thank you so much. I appreciate it very much. Thank
you can send an email and we will respond.
I will do that, sir. I will do that, sir. Thank you very much.
Okay. Any other question?
Well, this is Radhakant Padi here, IIC. Professor Kamakoti, thank you very much.
Hello, Radhakant.
Yeah, I listened a very nice talk, overall summary, and in fact, a lot of things are covered. But somehow I felt that a lot of IIC related initiatives are somehow missed out. Is it?
So this was only IITs. So I didn't include IISc because it's done for IIT survey. We did for our inventive fair. Yes, I will include IISc, and we need to include all institutions.
I know. Yes, it's a very good presentation.
Yeah, that's why IISc was not there. So just
I know.
Right, I'm sure a lot of work is happening in the IISc.
Right. Possible to get a copy of your PowerPoint, maybe PDF?
Yeah, I'll send it across. No problem. I'll send it across to INAE, and you can circulate to all these people. This is for the same. Sure.
Thank you very much.
Sure.
Any other question?
Hello, everybody. Hello, Professor. Thank you so much for the talk, and it was so nice. I'm Sangeeta Garg from TCS, and I'm sitting in New Delhi, from New Delhi itself. I've seen that there is a strong need nowadays for the cognition and the perception, and especially from the neuroscience perspective, to look at where the IITs and IIMs, and the AIMS, especially can contribute, much great details. So I think there are other courses also that are getting launched in, especially in IITs also. And likewise in the AIMS, right, I would definitely recommend to include that other perspective of the technology. So yeah. I mean, is there anything which is going on here?
Right. So yes, we have a computational brain research happening at many institutions. IISc is one. IISc and IIT Madras are funded by a single funding agency. And that basically also has a very strong thing on cognition and perception. So what I had included here is basically more or less technologies that are already on TRL 5+, right? So which can basically reach the market very quickly.
Okay.
And yeah, of course, there are a lot of fundamental work that is happening in this area of perception in things, and that is very important. From people are trying to bring in a lot more of social behavior tools that could indicate social behavior from the perception point of view. But whatever I have put here are TRL 5 at least, which can surely go into the market today. So yeah, certainly fundamental research I have not included here, but it's worth looking at it as a separate vertical. Yes. Thank you.
Thank you so much, sir. Thank you so much.
Professor Kamakoti, I have a question. See, are there some joint initiatives in the areas of controlling air pollution or environmental assessment, as well as this climate change related problems? I mean,
Yeah, so there is a very big UAOI project, the Uchatar Avishkar Yojana project, wherein 4 or 5 IITs and also IIC has joined on specifically addressing the point of air pollution. So there are at least 3 startups at IIT Madras which are looking at pollution control. One such yesterday we had a demo, Sensu Air, which is basically trying to remove the they are generating filters and also monitors which can basically take the air and filter it out and give it, and can be put at different places. Each can handle around 1,000 square meters of area. So there are a lot of pollution monitoring systems also in place which can give you very accurate pollution data. And so these are some of the efforts that are happening, joint efforts that are happening. I'm sure there is one group, strong group working at IIT Madras and similar counterpart at IIT Delhi. I'm fully aware of that. But there are many more groups that are working, and also from an AI perspective, from a data science perspective also, trying to look at different data sets and trying to see how well one can use these data sets as training sets and make certain devices and tools that can handle comprehensively the issue of pollution. Yes.
Professor Kamakoti, you told everything that you spoke is about TRL5. So is this Hyperloop also TRL5?
Yes, in the sense that we have a for a cargo, it can become TRL5. So we have the pod running. We are also having the vacuum tube completely tested. Now we are laying the track for 550 meters. And if that goes well, we have already got multiple things. A cargo can go at that speed, right? That is very, and for a human, it is yet to be tested because there's certain other quality and quality assurance that we need to do, and there are other very important tests that need to be done when we want to send human beings inside. But for the cargo, yes, it is at TRL5 at this point of time. Yes.
That's very nice. Thank you. Probably we should visit that and see sometime.
Yeah. So the track, the entire vacuum tube is tested. You can come and see that, and also the pod. The laying of the track is on place, right? 550-meter track is on place. So within another 4 or 5 months, we will have the entire thing going there. You can see that it's very interesting. Things are moving very fast, like Hyperloop itself.
Okay. We should have a dedicated Hyperloop from IIC to IIT Madras, probably.
Yeah, very nice. I remember when I was a postdoc at IIC, Balki used to say that we should have a dedicated link from all the IITs. It was 90s, right? So earlier. That became reality, right? Now we have the NPTEL, the NKN, which is basically doing it, right? So this may not also be a difficult thing.
Okay. Any other question? If not, it's already past 5. So, on behalf of INAE Chennai chapter and on my own personal behalf, let me thank Professor Kamakoti. Thank you very much. In spite of your busy schedule, I mean, you made time for us and gave such a beautiful webinar, which obviously generated a lot of interest, as is evident from so many questions. So thank you very much, and we hope to listen to you sometime again in future when you have time. And thanks a lot to INAE headquarters, particularly Lieutenant Colonel Shobit Roy, the President of INAE, Professor Indranil Manna, and the INAE digital team for helping us all the way to host this webinar. And finally, thanks to all the participants, all the audiences, all the people who are in the audience and made the session very interesting and interactive by asking so many questions. So thank you very much. Thank you. And we'll let you know about our next webinar soon, hopefully. But maybe, yeah, as soon as possible. Thank you.